Hello everyone, you have started watching Vaaninomics, myself Dr. Gaurav Kumar Vani, and today we are going to talk about solving linear programming problems using MS Excel Solver. Let's begin. Steps: open MS Excel, and then each of these steps now I am going to illustrate in detail. If you want to write down these steps, you can pause this video right here and write down these steps, but I am going to illustrate each of these steps now. Step 1: open MS Excel, open a blank workbook. So we are going to do this and open a blank workbook. Right now I am just illustrating straight. Later on I will do all the steps at the end of the video and illustrate you a live practical example also. Then next, in menu bar, click on Data tab. Check if Solver option is present under Analyze section, and here you see that in the menu bar there is something called Data tab. In this tab there is Analyze section and there is something called as Solver option. In my case it is activated, but we'll also see what if it is not activated. In your case, what should you do? Next step: if Solver is not there, then go to File, Options, Add-ins. And here you see that if you go to File, click there, then one drop-down menu will come like this. And at the last of these, you can see there is something called as Options. Click on that and you will find that there is another window opening, that is Excel options, and within that you see there is some option called add-ins, and at the last in that window you see manage Excel add-ins. You can see this, and you press go button and a new window will pop up, something like this. So select solver add-in option and in this list and then press OK. Next, here we have a linear programming problem that we have discussed in our class. So it is regarding production of two different commodities, which the production levels are represented by x1 and x2, and it is a revenue maximization problem where urea and water constraints are there. Then steps, these steps I will illustrate now one by one. Now write down decision variables in the first row in separate columns from second column onwards. So you see the column A is left blank in the first row, and I write x1, x2 in the column B and C. Then in the next row I keep it reserved for values of decision variable, so I write their decision variable value. Then next step, in third row write objective function coefficients, and from next two rows onwards after these write technical coefficient for each constraint in separate row. So you can see the objective function coefficients are 4 and 5. Then I write coefficient, technical coefficient for urea as well as water constraint in the separate rows. Then next, in separate column use sum product function to create to calculate the value of objective function and LHS of constraint. And here you see I have created sum product in the first row, dth column, and I write a function sum product to multiply 4 with the value of x1, 5 with value of x2 in the objective function row, that is third row. And I have shown you the formula, but actually if you do this you will get just 0 0 0. You will get the illustration at the end of all these steps, live illustration. So you have dollar signs affixed using function F4 on keyboard to fix the cell reference for DCN variable value, so that when you drag it, the cell reference for DCN variable should not change. In separate column, write sign for each constraint. You can see here we have put sign after the sum product, and write RHS of each constraint in separate column. Remember, when we are writing this all, your whole problem in mathematical formulation should be on the right hand side, so that, or should be side by side, so that you can see and there shouldn't be any mistake. Then these steps again I will illustrate further. Then now open solver by clicking data solver. So this is the dialog box of solver, right? Here in the top of this you can read solver parameters, the name of this dialog box. Then in this set objective, you have to select the cell reference value of objective function. In this case it is D3, and you can see the active cell reference is also D3. Then you have to choose whether your problem is to maximize or minimize the objective function. Of course it is a revenue maximization problem, so I will click on max, and it is also the default. Then select a cell reference for values of DCN variables in by changing variable cells. Here the next thing is by changing variable cells. You can see the cell reference given is B2 to C2, that is our values of decision variables. Next, press add button to add constraints. Where is this add button? You see here, this is the add button. Upon clicking add button, a new dialog box will open, and let's see. So this is the dialog box that will open upon clicking the add button, that is to add constraint. So in cell reference, select the LHS value of the constraint. So this is the cell reference uh, where you have to put the values, and here we put the values of left hand side. So left hand side of the constraint is from D4 to D5. Then select the sign of that constraint. So a drop down menu is there. You will see in the live illustration this drop down menu is there for sign, and you have to select the appropriate sign. If all constraints are of different signs, then it is better to add them separately. If they have same sign, you can add it in one go. We'll illustrate that. And then in constraints, select the RHS value of the constraint. So here you have to put the reference for RHS, that is from F4 to F5, and you can see the active cell reference for that also RHS of the constraint. These steps again I am going to talk further and give details also. So then press OK in add constraint dialog box. Now the added constraint would be visible in solver parameter. So subject to constraint, you can see we have our constraints. Only one constraint, two constraints are there, but since we added them together, it is just one showing here. Then to add non-negativity constraint for all variables, you can check the option make unconstrained variable non-negative here. If you are doing simultaneously with me, you can pause this video and you can do, and then you can proceed further. These steps again I am going to illustrate you. Now select a method to solve the problem. Under drop down menu, select a solving method. So here there is a drop down menu where GRG nonlinear evolutionary method and simplex method. Three methods are there in this solver, latest version of solver. So we'll select simplex LP because this is the method we will use. And now press the solve button to proceed for solving the problem. As soon as you press, you're going to get something more like this. So this dialog box will open and the previous dialog box will uh, be shut or closed. Now you can say that the solver is saying solver found a solution, all constraint and optimality conditions are satisfied, and it is saying the default is keep solvers option. As soon as you press the OK button, you will get the solvers option only. But you should also go further, and you can see that you can select all the three reports answer sensitivity limits. I'm not going in detail of these in this section or in this video. We can have separate section and video for that. That will be later, but right now the purpose is that with the shift or control you can select each of these and then press OK. Then now once you do this, you get the updated values of decision variable, value of objective function, and LHS of the constraint. Value of x1 is 4.125, value of x2 is 2.625. Remember earlier we didn't put any value, we just left it blank. Value of objective function was earlier 0, which is now 29.625. And you can see urea and water constraint are satisfied. As you can see, LHS and RHS are equal. Now again we'll see this problem uh, solved through solver, a live illustration of whatever steps I said earlier. So let's begin our task. Here we have a linear programming problem on the right hand side, and now we are going to start. So x1 and x2 are our two decision variables, and I am going to write decision variable value. So here we can put any value of x1 and x2, but the solver will decide the value ultimately. So we write objective function coefficient. Then objective function coefficients are 4 and 5. 4 and 5. Similarly, for urea constraint, you can see it is 6 and 2. And for water constraint, it is 1 because x1 has got no other number than 1. It is 1 into x1, that is x1, and 3. Now we want some product. So ideally, when starting with the objective function, I could have done 4 into x1 plus 5 into x2. But for the next creating constraint, I will have to do it again. So what I am doing here is first I am multiplying 4 with, sorry, 4 has not come, 4 with x1 plus 5 with x2. So instead of doing it again and again, we have to first do product, that is multiplication, then sum it. So I will write sum product. This is the formula in Excel where we will select first our decision variable value x1 and x2, then press F4 in your system. Sometimes it is just F4, sometimes it is function F4, Fn F4. Then press comma. Now it has put dollar sign on B2 and C2 because doing this F4 will fix the values of these decision variables no matter how much you drag, where you copy the formula, this will not change. So now we are multiplying the values of decision variable with the objective function. Now if I drag it, there shouldn't be any issue. No matter where you copy this formula, the reference value of decision variable will remain the same. Now I have to write the sign which is less than equal to, let me copy from here. Then I have to write RHS of the constraint which is 30 and 12. 30 and 12. Now let me go to data, solver, and we can begin this here. So set objective. So where is our objective function? So here is our objective function. What does this problem says? Maximize Z. So here it is by default maximize. If it is not there, you press here. If it was minimum, you press here. So right now it is maximum, I am pressing here. By changing variable cells. So it means what would change the values of left hand side and objective function. So it means our decision variables. So the values of decision variable can change. Then add constraints. Since both the constraints are of less than equal to type, I am just selecting it together and also they are placed together. Then right hand side also together. See, there are so many signs: less than equal to, greater than equal to. If variables are integer, you put integer. If there are binary integer takes value of 1 and 0, you put 1 and binary integer. Then you may say that there is one more constraint which is non-negativity constraint. Since uh, uh, both the variables are greater than equal to 0, we'll consider them separately. If they were to be unconstrained, any one of these, I could have selected here and added. To add more constraint, press here, but right now I am not going to do so. Press OK. Your constraint is appearing here. It says make unconstrained variable non-negative. So these, by just checking this option, you get these constraint automatically. And you have to solve it by simplex LP. This is the method. Press solve and solver found a solution. All constraint and optimality conditions are satisfied. Solver found a solution, right? Keep solver solution yes. We want some solution which is given by the solver, which is right now x1 equal to 4.125, x2 equal to 2.625. I want to retain all these three. So press with the shift or control whatever, then press OK, and you will see this all the three reports: answer report, sensitivity report, and limit report are generated. You can see that your objective function value has turned out to be 29.625 compared to 0 earlier. The urea utilization is 30, availability was 30, so no slack. Water utilization was 12 compared to 12, so no slack. And this is what the answer we got in the graphical method as well.